Hello and welcome to your following trigonometry class. I am Mr. Marcus, your favorite summer school online math teacher. And today what we're going to do is we're going to review a little bit of how to find the 6 basic trigonometric functions in a triangle. And also we're going to talk a little bit about radians and degrees and how you would use a circle and how that's also fundamental in trigonometry. So without further ado, let's get started. And I have this triangle right here. It's a 90-degree triangle because remember that the 6 basic trigonometric functions only apply to 90-degree triangles. And we know that we have our sine, and we can say that the sine is z. In this case, it's opposite over hypotenuse. And we can say that the cosine of z, which is adjacent over hypotenuse. The tangent of z is opposite over adjacent. The cosecant of z is hypotenuse over opposite. The secant is hypotenuse over adjacent, and our cotangent is adjacent over opposite. Now, in this figure, I need to find one of the sides of my triangle and all 6 basic trigonometric functions. So we use the Pythagorean Theorem, which is basically c squared equals a squared plus b squared, or sometimes you'll find it as a squared plus b squared equals c squared. Anyway, in this case, our hypotenuse is c, so we'll say 4 squared equals a, which is in this case 2 squared, plus b squared. So 4 squared is 16, 2 squared is 4, plus b squared. And what I want to do is isolate for b, so I'll subtract 4 on both sides. And this is going to cancel out, and this will be 12 equals b squared. Now I need to find the value of b, not the value of squared, so I need to find the square root of 12. Now the square root of 12 doesn't have a perfect radical, but you can use a calculator, and that's approximately 3.46 more or less. And that's the value that we're going to use to right here. So if we're going to find the sine of z, sine is opposite over hypotenuse, so that would be 2 over 4. And I can actually reduce this, and it will be 1/2, because remember, whenever we're working with ratios, we leave them expressed in our simplest form. Cosine of z, which is adjacent over hypotenuse, in this case, adjacent is 3.46, hypotenuse is 4, and we can just leave our answer expressed. I mean, if you have a calculator, you can divide that and you'll get a more precise value, but if not, you can leave like that. Our tangent, which is our opposite over adjacent, so we'll say that the tangent of z equals 2 over 3.46. And then we have in this case, the cosecant, which is the opposite of the sine, so we'll say it's 4 over 3.46. Cosecant of z, equals 4 over 3.46. Our secant is our adjacent, or our hypotenuse over our adjacent. I'm sorry, I made a mistake. This is pardon me, I made a mistake here. The cosecant is the hypotenuse over our opposite. So the cosecant of z is actually 4 over 2, which is 2. The secant of z is our hypotenuse over our adjacent, which in this case would be 4 over 3.46. And our cotangent, which is the opposite of our tangent, so it would be adjacent over opposite, which would be 3.46 over 2. So this is just reviewing what we already did. In terms of finding the trigonometric ratios, or the 6 basic trigonometric ratios, which we've done before, okay? So I'm actually going to go ahead and erase this, and let's move on to the topic of this video, or the next topic of this video. So we're going to talk about radians and degrees. Now so far, we've seen the 6 basic trigonometric functions, and tomorrow we're going to see a little bit of trigonometric identities. But trigonometry is a lot more than just right angle trigonometry. We're just seeing an introduction to it, but there's trigonometric identities, trigonometric functions, trigonometric equations, and a whole other series of concepts that you will find a little bit further down the line and in other YouTube resource videos as well. So what we're going to do is we're going to talk about trigonometry, but related to the circle. Now a circle has an angle, and if you look at a watch or at a clock, those old clocks that used to hang on every wall when I was a kid that had the little hand and the big hand, right? That's an example of a circle or angles, because you have, if you look at the short hand and long hand, they're like angles. So we call this side our initial side of an angle. We call this side the terminal side of the angle, and where they meet we call the vertex. Now that's true for all angles, not just necessarily with a circle. But if you notice, there's an angle that's formed between the terminal side and the initial side, right? And we call that a radian. In fact, we can define a radian as the measurement of the central angle of a circle, in other words, right here. And the degree is the rotation from the initial side all the way around to the terminal side. Now we have positive rotations, which are counterclockwise, and negative rotations, which are clockwise. And that is a little bit that you can find other great resources that will help you give you that information more in depth. Right now, all I want to do is just talk on how we work on the basis of this type of circle measurement. And it's radians and it's degrees. And there's a formula that helps us convert from a degree to a radian and from a radian to a degree. And what I'm going to do is actually I'm going to explain to you guys how you do that real quick. Now, if I want to go from a degree to a radian, the formula is pi over 180. And if I want to go from a radian to the degrees, it's basically the same formula but upside down, 180 over pi. Now I have some examples here. We have 135 degrees and 540 degrees. So what I want to do with 540 degrees and 135 degrees is I want to turn them into radians. I'm actually going to step out of the camera just to make sure that my equipment is working properly and that there is no issues with the camera. I'm going to see if I can actually, pardon that for a minute, and see if I can zoom in just a little bit, or actually write those numbers larger. Alright, and we're checking and everything seems to be good on this side. Alright, so let me just write this a little bit larger, okay? Let me just say 135 degrees. I don't see if I can write a bit larger than you guys. So the first formula is pi over 180. And the second, which is from degrees to radians. And from radians to degrees is actually the opposite. So our first angle is 135 degrees. So I want to go from degrees to radians, and our second one is 540 degrees. So if I want to go from degrees to radians, all I need to do is use this formula right here and write 180 and pi. And what I'm going to do is I'm going to multiply 135 times pi, which is actually 135 pi over 180. Now what I want to do now is reduce the fraction, because this fraction can actually reduce. Now you use your rules of divisibility. One of the rules of divisibility states that if I have 5 and a 0, I can divide each number by 5. So we can actually go ahead and see that. And let's say 135 divided by 5, and that would be 2 times 5, which is 10, and that would be 3. And bring down the 5. So this would be 27 pi, and 180 divided by 5 would be, the closest number I can use is 3, which is 15, and 8 minus 5 is 3, so 36, and that would be 27 pi over 36. But I can actually reduce 27 pi, or 27 and 36, if I divide each term by 9. And 27 divided by 9 is 3, and 36 divided by 9 is 4. So my answer is 3 pi over 4, or 3/4 pi. Okay, so in this next example, we're going to do the same thing but with 540 degrees. Now, the formula continues to be that if I'm going from degrees to radians, I use pi over 180. So you have 540 multiplied by pi over 180, and that would lead to 540 pi over 180. Now, what you want to do here is find a common factor between 540 and 80 and then reduce your fraction. In this case, it would be 90. And 540 divided by 90 is 6. I bring down the pi sign. And 180 divided by 90 is 2. So I have 6 pi over 2, but I can actually reduce that. I can just divide 6 and 2, which is 3, and that would be 3 pi. So whenever I go from degrees to radians, that's pretty much the formulas or the steps I take into account. Now, we're going to do the opposite as well. We're going to go from radians, and we're going to go from radians to degrees. So if we're going from radians to degrees, the formula that we're going to be using is this one. So if I have, like I do over here, negative pi over 2, or negative pi halves, and I want to turn that into an angle, I'm actually going to say, well, 180 times pi. And what's going to happen is that the pi's are going to cancel each other out, and I can also cross cancel 180 by 2, and of course 180 divided by 2 is 90, so that would be negative 90 degrees. Now what I did here is I cross cancel. 2 divided by 2 is 1, 180 divided by 2 is 90, and that's my answer. And if I want to do the same thing with pi over 6, so I do the same thing, 180 over pi, and then this cancels out, and I have 180 and 6, which also cross cancel, and basically my answer would be 6 divided by 6 is 1, 180 divided by 6 is 30, so this would be 30 degrees. Again, what I did here was I cross canceled 180 and 6. By which number? Well, 6, because, well, 180 divided by, or 6 divided by 6 is 1, and 180 divided by 6 is 30. And then, of course, 30 over 1, which is 30 degrees. Alright, so that's pretty much how you solve these exercises. I did leave, along with this video, some practice problems for you to do. So stay safe, and I will hope to see you soon. This is your favorite math teacher signing off. Bye.